Good evening. I'd like to welcome everyone to another screencast of Mr. Klein Mathematics. Today we're going to talk about areas of triangles on a grid. Before we start, I'd like to remind you of a couple of things. Vocabulary terms are in purple, and you can pause the video at any point to write notes or try examples or to just think about what you are seeing. And we're going to begin again with a grid. And we're going to draw a triangle on here. And the first thing you'll notice is that it's harder to find the area of a triangle than it is a rectangle. And that's because of the slanted line. If you try to fill this with tiles, they don't quite fit properly and you get kind of imprecise answers. So in order to find the area of the triangle, we're going to employ kind of a trick. And what I'm going to do is I'm going to draw a rectangle around the outside of that triangle. Now the rectangle, of course, is very easy to find the area of. And so we're going to start with that. And I'm going to remove the triangle to make that a little easier. So the rectangle has essentially 2 rows of 8, and we can easily find the area of that rectangle by multiplying those two numbers together. 8 times 2 is 16. So the area of the rectangle is 16 square units. But one thing you'll notice if I put the triangle back in is that the triangle is exactly 1/2 of that rectangle. And that makes the area of the triangle very easy to find. Because if the area of the triangle is 1/2 of that rectangle, then that makes the area of the triangle equal to 8 square units. And so that may bring up a question. That is the area of a triangle always 1/2 of the rectangle drawn around it? Let's look at another example and see if that helps us. I'm going to draw a slightly different triangle, a bigger triangle. This one's not a right triangle. But I'm going to go ahead and I'm going to draw the rectangle around the outside, and I'm going to fill this in. And let's look at this. Now, the difference is that this triangle is drawn a little differently than the one before, and it may not be as obvious that that triangle is in fact exactly half of the original rectangle. I mean, if it's true, the rectangle itself is 8 across and 5 up, so the area of the rectangle is 40 square units. And that would mean that the triangle would have to be 20. But let's look at this a little closer, because you may have a question of whether it's exactly 1/2. And let's start by drawing a line down the middle, essentially forming the whole shape into 2 smaller ones. Each of the 2 smaller shapes that you see are actually, in a sense, identical to the one that we just looked at a few minutes ago. The one up on top, which is 8 by 3, has a triangle that is exactly dividing the whole rectangle up there in half. And we also have a triangle that I've drawn down below, and it divides its rectangle in half. So essentially we have 2 smaller rectangles, each of which have been cut in half. And that means that the whole shape should be, logically, 1/2 of the rectangle. And since the rectangle is 8 by 5, or 40 square units, we can essentially apply the same idea, and that is that the triangle itself will become half of that rectangle, or 20 square units. In fact, it does turn out to be true that the area of a triangle is always 1/2 of the rectangle drawn around it. And again, I'd like to thank everyone for listening to this and watching this screencast. And again, I'd like to offer you a nice day.